We're very pleased today to have Don Perkins, the Executive Director of the Gulf of Maine Research Institute, present to us on his facility. We worked with Don a few years ago on the design of this facility for what is really an extraordinary vision that he and his group had. They bring together the working fishermen and women of the Gulf of Maine, research scientists which have facilities in their labs, and the local community and stakeholders. They bring these people together in a neutral environment and work together in a collaborative fashion to try and find policy solutions. The excerpt from the presentation you're about to hear is about the educational piece.
So to the education side, we're operating off of 3 platforms: the web, in the lab, and out in the field. And really the hallmark of what we're doing is immersing students in science. You all have grappled for years with science museums, aquariums, with the question of how do you engage people with the content? How do you go beyond the average stay time of 20 or 30 seconds to show them the artifacts of science? And then how do you do it extensively enough so that you really have an impact? And early on we concluded that, okay, the way to do this is if we could get to every kid in the state with a profound science experience that was sticky, that had before in the ecosystem. And so they work in groups of 4 in these digital lab environments, and they work through 4 different labs, each group, and the question is, what does the fish eat? And so they have a digital microscope, they've got prey identity cards here, they've got rubber gloves, they've got a dead X fish on ice, and so we walk up to the scientific method. We start by observing, they start looking at the mouth, does it have teeth? They realize that these prey identity cards, they try to figure out what it is that might fit in the mouth, and then this is a digital video camera. They film it, they videotape a hypothesis. One of the kids, they figure out who's going to do the hypothesis, and they do the hypothesis. And then they test that hypothesis. What does the fish eat? Well, you look at what's in its guts, and so they can call up a video of somebody dissecting a fish, so we don't have to clean it up every day. And then we have little plexiglass dishes that have fish guts inside them, and the kids look through the digital microscope and try to figure out what it really was in the fish's guts. And then they record a conclusion. Very simple idea. It's an experiment. Your users kids love this. Then we have a fish tank, a schooling tank with a video camera in the top of the tank, where you watch the swimming behavior. And the question there is, why don't they bump into each other? What are the rules of school? So the kids hypothesize those rules, and then they test them running around the tank. And you walk in there, and there'll be 12 kids running around this fish tank. You say, oh, those kids are out of control. But you look at their conclusions, and they're every bit as provocative as what the kids are doing in the other stations. To the question of sticky, you can see that this is all networked. You can see what these kids are doing in each lab the whole time they're there. Everything digital they do, we can see and we record. And we build each student a personal website that has the 4 hypotheses they did, the pictures they took, the diagrams they drew, the videotapes, and we send them home with a CD that goes in any computer, launches them to our website, they type in a little personal PIN number, and at that point they can interact with us one-on-one, or their whole class can work with us. We've got about 3,000 learning activities that a teacher can draw from. And so back to the question of sticky, it's designed so a kid can stick with us, a class can stick with us. We've already got 6 school systems that have used this to reprogram their entire year.
Are those the school districts?
Yeah.
The outreach?
Yeah.
And then